Hello and welcome to Domsolar for this new training session. I'm Stefan Arwe, and today we're going to look at the EB solar system. The EB solar system consists of a plate that is attached to the top of the ribs of a trapezoidal tray. It is certified with an ETN, which means it has undergone a new technical investigation by the Alpe Control Inspection Office. In this ETN, we are working with a purlin spacing of 1.60 meters on a 0.75 millimeter tray. Of course, we also work with 0.63 millimeter trays, and we prepare calculation notes for much larger spacings. I also recommend that you regularly visit our website to download this ETN, as we frequently add updates with module amendments and also different types of trays. The EB solar system can also be installed near the sea, that is less than 3 kilometers from the coast. For this, stainless steel A4 screws will be used, whether for securing the modules or the mounting plates. One important thing for the EB solar system, the plate is only installed at the top of the lower rib. In terms of width then, at 26 millimeters. Before installing your system on the roof, of course, your project will have been studied. And for that, you need to provide us with as much information as possible. The layout plan, the plans of your framework with the different heights, ridges, slopes, the slope percentage, the module's technical data sheet, your layout plan, and the technical data sheet for the steel tray. The EB solar system is installed only on the tray, meaning it stops before the ridge flashing sheet. For this, we allow a default margin of 35 centimeters. If on your roof the tray is already installed and it's fixed with hooks or clips, you will need to check using a plate equipped with its fastening. If the module can fit without removing your hooks, once the quote is approved, we carry out the final layout with a list of the different parts. Please note that EB Solar is installed only in landscape mode with a 9 millimeter gap between modules in the row. At the top of the generator, your plate will be offset by 5 centimeters compared to the module, and at the bottom, it will be offset by 85 millimeters. Be sure to take these dimensions into account. By default, we use a 9 millimeter gap between columns. If you want a larger gap, you must let us know this measurement during the study. Now, I will show you on the screen the different parts of the EB solar system. So EB Solar has two types of fastenings. The intermodule fastenings here are equipped with a clip that allows you to ground the module frames when attaching the fastenings. It's very simple. You have your plate with a small groove here, and you simply clip it directly onto the rail. I'll put it in this direction. There you go. The intermodule fastening is now complete. Hex key, 5 millimeter diameter, tightening torque, 10 Newton. The external fastening, same thing, it clips in right here. So you'll find it at the top and bottom of the generator. At the bottom of the generator, you'll need a locking piece, which is called the CTR. So that particular component will come right after your plate fastening system, which is crucial. The external fastening, same thing, 5 millimeter hex key, module tightening torque, 10 Newton. The CTR generator stop, a 3 millimeter hex key, requiring a tightening torque between 2.5 and 3 Newton meters. Again, at the top of the generator, you'll be more in this position, no need for a CTR. CTR only at the bottom of the generator, not on the other plates. The plate is 13 centimeters, pre-drilled with 2 holes, and uses Fino screws 6.3 by 38 millimeters with a stainless steel head. When tightening, actually start with your screwdriver at the lowest setting, because it's really, with regard to the gasket here, you shouldn't crush it too much, just enough to ensure it's watertight. The plate also comes with a gasket already installed. And then it may be that for your project, you'll need optimizers or microinverters. Just so you know, don't hesitate to ask. We'll actually provide you, not the microinverter itself, but the plate with the mounting hardware. For the microinverter, now, you need to be very careful with the microinverter because if you're working with a tray that's less than 45 millimeters, you'll need to equip your microinverter mounting with an EPDM gasket. The microinverter, you'll just need to install it here. We'll also look at that in the presentation. The CTM, which allows you to ground the first and last column of modules. We'll see that there's another way to ground the system, but only under certain conditions. Also know that if you want to secure your cables, it's entirely possible to add a Pascal clamp to the plates, even when they're already fitted with your mounts. But that's optional. When you get to your project, you'll need to check certain things, such as the dimensions of your roof with us. We'll provide you with a plan showing the combined codes. So on the slope, you'll need to be very careful if you come across rafters, especially when attaching the modules or the plates. No impact drivers. In fact, with the combined codes, what you'll be able to do is already identify it, where you're going to start installing your plates. If you ever happen to hit a purlin, you will definitely need to carefully remove the purlin screw, then gently take out the associated bracket, and you will always have the important option to properly install the specialized plate. And no matter where you are located on the structure, you will absolutely need to meticulously put that same screw back through the newly installed plate and securely fasten it to the purlin itself, ensuring a strong and stable connection. And you'll add the 2 stitching screws, obviously to secure your plate. Please be very careful, as all of the corrugations must be securely fastened, which specifically means that every single corrugation of your entire tray absolutely must be firmly attached to the purlin without exception under your generator. You won't be provided with the screws and brackets. So make sure to plan the order in which you'll secure the generator. Of course, what I forgot to mention is that the screw you'll put back through the plate must be fitted with a vulcanized washer to ensure water tightness. Once you've checked your plates on the slope, you'll also need to check on the tray's corrugations where your plates will land. What we recommend at Dom Solar is to make 2 gauges to the right dimensions of the module, plus the gap you set here, which is 9 millimeters by default. You can choose whatever you want, but be careful. We prepared your calculation note based on the information you provided to us or not. That is, by default, it's 9 millimeters. If you chose 20 millimeters, we would have done the calculation note based on 20 millimeters. This is important because in the calculation note, we indicate on the plans where to start in relation to your edge. The measurements are very important when we put them on your plans. It's based on a calculation note. If you change it, it could actually be detrimental to your study and especially to the integrity of your system. Following the calculation note that we will have made and the recommended measurements. So create 2 gauges with the dimensions of the module plus a quarter. With the markers between 0 and 13 centimeters, we don't put a plate. And then after that, there's plus 33, so it's the same on each side. Then you know where you're going to start, for example. We're at the edge of the roof, you're going to start your module here. Obviously, on the tray, it's forbidden to be outside the tray. You'll have a marker here, so you'll mark it on your corrugation, and then as you go on each corrugation, you'll be able to move forward. Move forward with 2 gauges, so you need at least 2 people, because you have to hold your gauge properly on the tray, and then another gauge is cut, and you actually bring the 2 gauges end to end. It's much easier, and you bring them end to end, and you move forward, and you do mark your tray waves with 2 distinct marking sprays of different contrasting colors. Use 1 spray to clearly mark the precise gaps between the individual modules, and utilize the other spray to accurately mark your plates. It may occasionally happen that at some point during the process, you inadvertently end up with an HL mark on two adjacent waves. Well, what you need to do is go check the other wave, on the right the other mark, because normally you should only be on a single wave. So you're going to mark your wave here, you'll mark it, and the gap between two plates in any case is at least 1 meter. So if you're straddling two waves, one wave here and one wave here, you take 1 meter and you always normally have about 40 centimeters between the edge of your module. And the plate is about 40 centimeters. There are module manufacturers now who divide by 5 the length of your module and give you a range of plus or minus 50 or plus or minus 100. It depends. So make sure to check the module manufacturer's instructions, but in any case, by default, we provide you with this gauge. Now, as for the markers, the gauge is not provided for your project. As I was saying, it's to equip yourself with 2 marking sprays, one to mark the gaps between the modules. Now, some people don't even use gauges anymore. They just roll out their tape measure over 50 meters or 30 meters, depending on the scale of the project. They'll actually mark the gaps between the modules, and once they've marked them, they know which areas will be next to each other on the inside. Between your markers, that is, it's about 33 centimeters apart. Next, well, you'll need to snap a chalk line for your first base plates at the bottom of the generator. So either you have a good eye and you snap your chalk line by sight. So earlier you marked where each base plate will be placed. If you manage to avoid the rafters with the combined codes, you try to check. Otherwise there will be rafters, and of course you'll have to remove those specific screws. Keep in mind that you have to put them all back, and all your corrugations under the generator, all the wave peaks must also be fixed to the purlin. So to start, there's a method, one among many, but it's the well-known 3-4-5 method. Now let's assume the tray is straight, which isn't always the case, but you have to start somewhere and use something as a reference, especially since we're following the rib of the tray, so we won't have much choice. We're going to make a 0 point to indicate where our first plate is. We'll measure 3 meters up to the top of the tray and mark a reference point. Next, from our 0 point along the gutter, we'll measure our famous 4 meters. Now, wherever we end up, it's not obvious that it'll be at the top of a rib, but we'll try to make a small arc. And then once we've made our 3 meter and 4 meter marks, we draw our 5 meter diagonal and we make another small arc and cut our pair. And now we can mark with the Cortex, so with methylene blue, at least the bottom of our plates. Next, since we've marked all our ribs, we can at least place the first and the end of our plate. And then we can proceed. Also, the famous CTRs to put a chalk line back and be able to fix all the plates. Then we have our cumulative measurements. So we could be at 1065 or 2 meters. In short, we have our cumulative measurements and we transfer the first and the last. So do this every 15 meters. Because 20 meters, 30 meters, it's better to start again in several places rather than doing it over 30 meters. Because you'll see your chalk line will get distorted and you'll never be straight. What's important is that your first plates at the bottom of the generator must be perfectly aligned. Same thing, you start again with the chalk line and put your plates back, etc. Repeat this each time so you can place them and use the chalk line all the way to the top. Be careful, no impact drivers, only use regular screwdrivers. Once you've installed your plates, also keep in mind that when you start installing your modules, you'll need to ground the top of your first row and your last row. Anything that's offset, either with CTMs, these are provided by default, they slide under the frame of the module. So here, this is a CTM equipped with a green and yellow wire. Generally, you'll be using a flexible 6 square millimeter wire, and you slide it under the frame of the module here. And you tighten it to 2.5 to 3 Newton meters. Same for grounding the module, so the green and yellow wire here. Be very careful. When you tighten the green and yellow wire, make sure the tip actually strips the insulation and makes contact with the copper. And above all, don't screw it in all the way so that it presses against the aluminum, because then you'll actually make the copper and aluminum touch. And that's not a good combination. Use a 3 mm diameter to tighten this CTM to the frame or to connect the 6 square millimeter green-yellow insulated wire. There's another way to ground your EB system. It's by grounding the mounting tray via the CTM here, which is directly connected to the electrical ground, and you will also need to carefully connect it to the metal tray, ensuring a secure and proper connection. So the easiest way, obviously, would be at the top of the roof under the cladding sheet, and maybe you'll need to connect it at several points on the tray. It's up to you to make sure that the tray, throughout its length, is connected to the ground, so that there is indeed an equipotential bonding between all the trays and between the mounting plates. But before you go ahead with this second solution, you really need to have it approved beforehand by your electrical inspector. Earlier, during the presentation, I told you that you also have the option to request the mounting plate and the installation of a microinverter or an optimizer. You just need to be careful with the installation. Here, the well-known mounting of the microinverter. Here, a small optimizer that you tighten as much as possible. And what you really need to pay attention to is the air gap between the heatsink here and the mounting plate, and between the heatsink and the tray. 10 millimeters. And for a tray with a wave height of less than 45 millimeters, you will need to use the mounting equipped with a PDM gasket, 10 millimeters. To install your modules, you will always start at the bottom of the array and work your way up row by row. You install the first row, the second row, the third, and so on. Be very careful. The bottom of the array must be aligned with the chalk line, as well as your modules, but normally your CTR, the bottom of the array, will come up against the screw. You could very well have a slight offset. Don't hesitate to install your first module and then use a chalk line with a CTR. It can be handy. The outer mounting and then the module mounting with the malt clip. At the top of the array, you have a rail, as I mentioned at the beginning of the presentation, which will extend 70 millimeters. And at the bottom of the array, your rail, your plate, will extend 85 millimeters. So if you ever need to do your flashing, know that this is the width of your setup, plus the 9 millimeters between each row, but there is an overhang of the rails at the top and bottom of the array. Don't forget. I'll repeat myself, but for the mountings, no impact driver, use a 5 millimeter Allen key, tighten the modules to 10 newtons, the CTR Allen key is 3 millimeters, tighten to 2.5 to 3 newtons. And finally, what you should take away from this training, which is coming to an end. No mounting at the ridge. Tighten the modules to 10 newtons, tighten the CTR to 2.5 to 3 newtons. You can install less than 3 kilometers from the sea. Be sure to specify in the pre-study the exact location or the GPS coordinates. And we will provide you, whether for the module mountings or the base plate screws, with A4 stainless steel. Some areas and the spacing to be respected. Afterwards, and as I told you from the beginning, we can prepare a calculation note so that it can work. Don't forget to visit our website. There are small software tools that can also help you check if your module meets the certification. You can download everything related to ETN or technical approval, depending on the type of system you are going to install. And then, following this training, if you have any questions, don't hesitate to send me an email or call Dom Solar today for assistance. Well, I wish you a great start to your project. Thank you for listening. See you soon. Goodbye.